Okay, so sine law, ambiguous case. So we talked just briefly at the end of the block yesterday that we were going to look at this today. Ambiguous meaning not clear, or more than one option. So when we're using the sine law, as you found yesterday, hopefully when you were doing your assignment, it's pretty straightforward to use. But there is this one type of question that we could give you where you have to be super careful because there's actually two different ways that you can make that data fit. So those types of questions we call the ambiguous case, and they occur when you are given angle, side, side in that order. Now, if I give you the diagram, there's no ambiguity. In other words, it's pretty clear what the triangle is because I'm giving you the triangle. So these types of questions are when the triangle is described to you, but not drawn for you. All right? So let's say you're asked to solve triangle ABC with angle A equal 40 degrees, side C equal 30 centimeters, and side A equal 22 centimeters. So in other words, I'm giving you the information about the triangle, but I'm not giving you a picture of the triangle itself. So I want you to try and draw that triangle for me. So draw that triangle, label it with the data that's given, show where the other sides would be. Sketch me a picture. So how many people drew a triangle that looks something like that? Excellent. All right. So that is one possible case. However, there's no reason why I couldn't take the same measurements and draw my triangle this way. Is there? So, because there's two possible ways to draw this triangle, we call this the ambiguous case. So, I happen to have, this is the math department's infamous ASK tool. See, Mr. Tam used to be the department head, and this is his. ASK tool stands for angle, side, side. Not trying to be rude. All right. So here's my known angle, 40 degrees. This side on the bottom, I have no idea what length B is, right? So length B can have any length. This side is fixed in length, right? This is my side C. And this side is fixed in length. This is my side A. So I can draw a triangle like this, which is the way most people draw it initially. But there's absolutely no reason why I can't swing that side around and have it drawn this way. Okay? So this one, all the angles are acute. Well, not necessarily. This one at the top could be obtuse. This one, this angle down here, clearly obtuse. Okay? So we call this the ambiguous case because we don't know which way that triangle is to be drawn, which means that we have to solve both. All right? Now, one of the things that you're going to be asked to do is to determine whether or not two triangles are possible. Okay? So, just because we give the angle the side and the side, it's not necessarily always going to be the case that you can draw two triangles. Certain conditions have to be true. All right? So, for example, if this length here was longer than this length here, so length A is longer than length C, you couldn't draw two triangles, right? You'd have this side way out here, but when you swung it around this way, it would hang out underneath. Does that make sense? If you think of this diagram. So if this was, say, 42, I could make a triangle way out here, but I couldn't swing it around and make a closed triangle this way. It would be longer than this, it would stick out. So the first condition that has to be true for you to be able to have two triangles is the side opposite the known angle has to be shorter than the other given side. Okay? But it can't be too short. So what would be the shortest possible length that side A could have so that we could still form a triangle? Yep? Absolutely. Excellent. If I take this length across from my known angle, the shortest it will ever be is when I form a right angle at the bottom, right? As soon as I go out here, it gets longer. As soon as I go out here, it gets longer. Its shortest possible length is where this angle, at angle C, is a right angle. Okay? So this length has to be longer than that shortest possible length, but shorter than this length in order for there to be two possible triangles. All right, so we have to check because there are three options. You can make one triangle this way only. You can make two triangles this way and this way. Or if I cut this off, you can make no triangles. So one of the questions that you'll be asked is how many triangles are possible with this data, with these given dimensions? And you have to be able to determine that. And so part of that work will always be calculating what the shortest possible length is. All right. More or less got that?
Okay. Repeat the rule about the length.
Okay, well, I'm going to write it all down so that we have it. So, since two triangles are possible with the given information, we call this, the ambiguous case. When you have angle, side, angle, three possible scenarios. No, there are three possible scenarios. Number one, no triangles possible. And this occurs if the length across from given angle is shorter than the height of the triangle. So I'll give an example with the data that we started with. So if this is 40 and this is 30 and This is our other side. The height, what I'm talking about, is coming straight from that top point down to the base at right angles. So that's our height. Now how could we calculate that height? How do we find the height? We have this angle and we have this other length that we know. So what would we do to calculate that height?
Use the sine law.
I don't need the sine law, we just need straight on sine because it's a right triangle, right? So this is opposite over hypotenuse. So the sine of 40 equals h over 30. So h is equal to 30 sine 40. So in this example, (30 times sine 40) is 19.3 centimeters. So we know that 22 is long enough to make a triangle. Okay? Does everybody follow what I'm doing here? So I need to calculate what that shortest possible length is to make sure that side A is long enough to actually be able to make a closed figure. That's not going to be sort of dangling there and never been able to reach that bottom. All right? So this is the shortest possible length. So you can have one triangle. And that's if the length across from the given angle is longer than the other given length. So if it's longer, you can only make one triangle. And that's, so done. Draw that one triangle, solve it. The third scenario is two triangles are possible. And that's if the length across from the given angle is between the shortest possible length, which is the height, i.e. height, and the other given length. So as long as this side, this is the key side, this length, this is the one we have to check. As long as this one is between the length of the other given side, which is up here at the top, and the height, which we would calculate, if that's true, if it's between this and the height, then I can make two triangles. One with the obtuse angle at the bottom and one with an acute angle at the bottom. Okay, everybody still with me? Okay, so let's go back to our original question, and we're going to look at the two cases. So case one is the way that most of you drew it initially. Where A was 40 degrees, side C was 30 centimeters, side A was 22 centimeters, and we formed it by going away from A instead of towards A. And case B or case 2 rather, same measurements, but now we swing it back towards A when we complete the triangle. Some people find it helpful to draw one triangle initially, and draw both of their options like this. So that might be more helpful visually for you to put them together first to see, because now you can see where your two options are, here and here. And you can also see that shortest possible length is in the middle. So if that helps you to draw it as one initially and then do your two cases from there, then by all means use that. Just a minute, I'm going to see if I can move this. So I'm going to move it up here out of the way. So from that, you get those two cases. Okay, so we have to now solve this. So we know from yesterday that solving means find all the missing pieces and all the all the missing angles and all the missing sides. So we'll start by finding angle C. So the sine of 40 is to 22, as the sine of C is to 30. So sine C is 30, sine 40 divided by 22, which is 0.8765. So angle C backwards in my notes. 61 degrees. Once we know what angle C is, then we can easily find angle B by going 180 minus 40 minus 61. So angle B is going to be 79 degrees. And now all we have to do is find side B by using the sine law again, and I'm going to use my original information always. So sine 40 is to 22, as sine 79 is to B. So B is 22 sine 79 divided by sine 40. So B works out to be 33.6 centimeters. Thank you both. All right. So that's nothing new. That's just what we were doing yesterday. Everybody's okay with all that? Now, we have to do the other triangle. And it's not as much work as it might seem to do a whole other triangle, because if I'm to go to do this triangle, first of all, what do we know about angle C? How is it different than it was in the first triangle? It's become obtuse. Everybody hopefully can see that. It has to be an obtuse angle. All right? There's no way we can draw that triangle without it being obtuse. All right. So that's what we talked about at the beginning. We have two options with sine. It gives us the reference angle. So if I was to go and find this angle over here, I would again go sine 40 is to 22, as sine C is to 30. Exactly like I did in the first one. So why would I calculate all that again? Because I'm still going to get 61 degrees. But of course, that's now the reference angle. So in the second case, to find angle C, we're going to take this angle and just go 180 minus that angle to get the value of C, which is now the obtuse angle. Right? We don't have to do all those calculations again because we're not going to get any different answer. We put it in our calculator, we're still going to get 61 degrees. And then we're going to have to find the supplement of that by subtracting from 180. So let's not do all those calculations again. Let's just use what we did in the first case. So that's why I always recommend that you do the case that has the acute angle at C first, because we're most used to finding the acute angle. And then in the second case, you know, all you have to do is take that angle from the first case and find its supplement. Everybody knows what supplementary angles are?
They add up to 180.
Angles that add to 180. All right. So then we've got angle C. So we've got angle C. Angle B is easy to find as well. We're just going to go 180 minus 119 minus 40. So angle B is 21 degrees. And it makes sense that angle B is going to be a lot smaller, right? Angle C gets bigger, B has to get smaller, right? So B may or may not be obtuse in the first case, but will definitely be acute in the second case. Okay? When I say it doesn't necessarily have to be obtuse, it really is dependent on this angle. If this angle is a bit bigger, then it won't be obtuse in the first case, but it will most definitely be acute in the second, and this one will always be obtuse in the second case. All right, so now all we have to do is find side B, or length B, and you can see that in this obtuse case, the length of B should be significantly shorter, right? Because I've swung this side in and made a smaller base length. So let's find that. So the sine of 40 is to 22 as the sine of 119 is to B. So B is 22 sine 119 divided by sine 40. So B works out to be 12.3 centimeters. So as we expected, significantly shorter than it was in case 1, where it was 33.6. So far, so good? Excellent. All right. Big idea here. And it takes a little bit of practice to get your head around it. All right. So let's see if you can tell me how many triangles are possible if for triangle ABC, angle A is 48 degrees, C is 12 centimeters, and A is 15 centimeters. So have a look at that data. Now, when you're sketching these, I recommend that you sketch them the same way every time. I sketch them one way. If I try and sketch them a different way, I mess it up. I just get so confused. So I always put my known angle in the corner. I always put my one known side here, and the known side that might flip both ways always goes opposite there. So I always draw my known angle, my known side, my known side. I always draw it that way. So, and I recommend you pick a way. It doesn't have to be my way if you don't want it to be, but pick a way that you do it every single time so that you don't get yourself confused, because it is confusing to draw them otherwise. So, what do you think? How many triangles are possible? Pardon me? As many as you want. No. Only one. Why is there only one triangle possible, Ryan? That's right. So here's my angle A. It's 48 degrees. If this is 12, because that's my side C, it always goes here, This is 15. I can only draw it out away from A. Because if I try and swing 15 back in towards A, then it's going to stick out. It's going to be too long. And I'm not going to be able to make a closed triangle. So only one, because A is greater than C. Yes?
If you put the lengths around, like say C was 15 and A was 12, could you have 2?
I don't know. Good question. Let's try. So let's do it again. Same question. And now we want to make C 15 centimeters and A 12 centimeters. Okay. Well, we have to check something. In order for there to be two, it's met one of the conditions for there to be two triangles. Namely, it's less than side C. But there was a second condition that also had to be true. So you're going to have to calculate that to see if it's long enough to actually make a triangle. Okay? So, finish that. Excellent question, Vinay. Thank you. I was going there in just like a slightly different way, but that's okay. All right, so we calculate the height, which would be the shortest length that we could allow A to have, and we find that the height is 11.1 centimeters. So since A is longer than the height, but shorter than the other given side, we can make two triangles, right? So we could draw our triangle this way or this way, with that height in the middle. There's our A, there's our 48 degrees, there's our 15, and that length is 12. So two triangles are possible. Because H is less than A is less than C. Does that make sense? HAC? Okay, so this is our height. This is our side, opposite, given angle, and this is our other given side. So as long as the side opposite the given angle is between the height of the triangle and the other given side, then we can make two triangles. So that would be a very straightforward, well, hopefully straightforward multiple choice question on a test. How many triangles are possible? 0, 1, 2, 3. Don't pick a 3 ever. Okay? All right, now, I want to talk about one more thing before I give you a full-on question to try. What would happen if angle A is obtuse?
I'm pretty sure you can only have one triangle.
Okay, so if angle A is obtuse, so I'm still going to draw my angle A here. This is still side C. This is side A. In order for there to be a triangle, what would have to be true of side A?
Longer than side C.
It has to be longer than side C, right? Can you see that in the diagram? If I make this angle obtuse, that means C has to go out this way. A has to be longer, because if this is an obtuse angle, there's only one obtuse angle in a right triangle. Or there's only one obtuse angle in a triangle, right? There can only be one. So, as we know, we talked about earlier, the longest side is always across from the biggest angle. So if angle A is the biggest angle, and it will be if it's obtuse, side A better be longer than side C. If it's not, there's no triangles possible. So if A is greater than C, one triangle possible. If A is less than C, no triangle possible. But it's impossible to have two. So I just wanted to talk about whether, because sometimes A will be obtuse. And so all the other conditions we just talked about become a little bit different. All right. I want you to try this one. Solve triangle ABC for angle A equal to 28 degrees, C equals 15 centimeters, A equals 12 centimeters. So, to solve it means to find all missing sides and angles. First thing you need to do is decide if there are 0, 1, or 2 triangles possible. If there is only one, then obviously you're only doing one. If there are 2, then you have to do both cases.
Is there a default way to draw it?
Nearest degree or 1 decimal place for angles. I always do at least 1 decimal place for lengths. So if in doubt, do 1 decimal place. That's because you're going to be using your answers to find other answers. It's better to have an extra amount of precision in your answers. So 1 or 2 decimal places versus rounding it to the nearest whole number. All right, so in order to figure out whether or not we have 2 cases or 1, we need to figure out that height and see if it is less than 12. So the sine of 28 is h over 15. So h equals 15 sine 28. Now, after you've done this a few times, you're going to notice that you're always taking the other known side and multiplying it by the sine of the angle. So if you go straight to this statement, I'm okay with that. So this works out to be 7.04, right? So 7.0. So since side A is less than 15 but greater than 7, we have 2 possible triangles. So because 12 is between 7 and 15. All right, so case 1, case 2. For case 1, I always want to do the acute angle at C first. So this is 15 and this is 12. Case 2. So 15, 12. All right. So we start off by finding angle C. So the sine of 28 is to 12, as the sine of C is to 15. So sine C is 15 sine 28 divided by 12, which works out to be roughly 0.5868. So angle C works out to be 35.9 degrees, or 36. Okay? That means angle B is 180 minus 35.9 minus 28, which works out to be 116.1 degrees. And we can use that now to find side B by doing the sine law again. So the sine of 28 is to 12, as the sine of angle B, which is 116.1, is to side B. So B is 12 sine 116.1 divided by sine 28. So B works out to be 23.0. What are we working with here? Centimeters. So there's the first triangle solved. Now, angle C is obtuse in the second case, and so we're going to use this value here to find angle C by finding the supplement of that. So we get 144.1 degrees. Angle B is 180 minus 144.1 minus 28. So angle B works out to be 7.9 degrees. Very small, right? And then all we're left to do now is to find side B again. So sine of 28 is to 12, as the sine of 144.1 is to B. So B is 12 sine 144.1 divided by sine 28. B works out to be 3.5 centimeters. So that's the work I'd expect on a question like that. I'd expect this work here, because you can't tell me there are two triangles unless you find that height. So that height is expected to be there, or that calculation. I expect the two diagrams. I expect the work to find angle C in the first case. I don't need the work other than to show that it's a supplement in the second case. Both times to find angle B, you're just subtracting the other two angles. And then finally the sine law shown for finding the last length. Yes?
When I'm doing the sine law, I just kind of plug the numbers into my calculator. I don't like write it out in those clubs.
Yeah, I would like you to do that.
You have to.
Which step would you like?
Yeah. It's just too easy to put in our calculators incorrectly. If we force ourselves to write it down, we're less likely to make those small errors. It's just about being careful in our work. I get that we can do it in our head, but taking that extra 15 seconds to write it down, it also kind of cements what we're doing, that process over and over. So that at the end of the year, when you get the term exam, you go, yeah, I've done this a million times. So I just would like to see that part. Good question, though. Anything else? Yes, Morgan?
For finding the length of B, you have in case 2 sine 144.1 over B.
Yes?
Wouldn't it be sine 7.9 over B?
Oh, yeah, it would be. Thank you. My mistake. Oh, see, there's why you should write it down. I don't know what I was thinking. We already know what side C is. Thank you very much for that. Any other corrections necessary? No, don't feel bad about that. I'd feel much worse if I put it up online and it was all wrong. People go, I don't get it. I thought I had it. Now I don't get it. Yeah, so, good. Thank you. All right. So, I have a handout for you because there is lots of work to do around ambiguous case, and there aren't that many questions in our textbook. So in the handout, you're going to go do numbers 6 and 8 through 13, and in your textbook, you're going to go back and do the ambiguous cases that I took out of the assignment yesterday. So 6, 7B, 9B, 14, and 15. And there's some really nice questions in your textbook, questions that we might see on a test, so make sure you do them.